My name is William. I'm studying electrical engineering.
Hi, my name is Jonathan. I'm an electrical engineering major.
Hi, my name is Ishan. I'm a math analytics major.
And this is our final project for ENG6, which is an audio interface. To begin, I created the audio sample selection, everything in here, and the save button and the playback direction button. And to begin with using our interface, what you do first is you import a file from your computer. So this is the file that you want to modify or that you want to work with. You press one of the load buttons, which corresponds to whatever sample number you want to load said file into. Then you click a numerical button, which basically assigns whatever file is in sample one or sample whatever as the file that is currently being modified and the file that's currently being played. And then you could play the file by clicking the play button. You could pause it by pressing the pause button. To resume it, you press resume. And if you want to play it all the way back in the beginning, click play. So when you play, it displays an audio waveform of the sound in the bottom left corner, of which the X is a time vector of the duration of the sound, and the Y is simply just the amplitude. In addition, you can add certain effects to the sound, like playing it forward or backwards. And once you click the save button, it saves the sound. And when I load the sound up again here, I play the backward sound. So when I was tackling this, the biggest issue I had was figuring out how to save all the modifications I made to one sound and figuring out how I can modify one sound multiple times. And the way I solved that was by creating the current sound system of where I select a certain samples to be the sound that is currently being modified, modify that, and I save it.
Okay, so my job for this project was to create and manage the effects and sample modulations. This includes our volume dial, our playback speed, our echo and delay function, and our equalizer. So to test out these functions, I'll import another file. Just load it up. And our default volume level is set to 100, but you can adjust the dial. And so the volume level of our audio file changes according to the level of the volume dial. You can also alter the playback speed of our files. For example, I can speed it up. Or I can slow it down. Or I can play it back to normal. And for our echo and delay function, what it does is it essentially creates a duplicate audio file, and based on the time or the delay time that you decide to set, it'll play the duplicated file at the set time after your original sound is played. So if I set my dial to 1 second, it will play the duplicated version of your audio file 1 second after the original has been played. As for our equalizer function, what the equalizer does is it changes the volume at certain frequencies. So for example, if I decide to up the volume of our audio file at 500 hertz frequency, you can hear that the 500 hertz frequency will be enhanced as we play the audio file. And so let's combine all these functions together.
Gole 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 wata lingango. Lingango, lingango, gole 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 wata lingango.
And
Lingango, lingango,
your
gole gole gole
modifications
wata
can also be saved in
lingango.
sample.
Lingango, gole gole gole
So
wata
if I save it to
lingango.
sample
Lingango.
2, and I load up sound 2,
Gole 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 wata lingango.
it will play the
Lingango,
modified
lingango,
version
gole gole wata
of
lingango.
our
Lingango,
audio
lingango,
file.
gole gole wata.
The challenge that I faced while coding my part of the project was figuring out how to separate the frequencies of the equalizer. It was a bit complicated at first, but I ended up deciding on the design filter function because it allows me to set ranges of frequencies that I want the sound to pass through.
My contribution to the project was implementing the synthesizer and the chopping audio. Let's start with the synthesizer. So the synthesizer can be found in this top right panel. And basically what the synthesizer does it's able to create sound using mathematical waveforms. So in this waveform section, this dropdown, we have 4 waveforms. We have the sine, the square, and then our special features, which are the triangle and then the AM wave. So we'll start with the sine. And we'll use a frequency of 440. Let's play. And as you can see, the sine has sort of a smooth tone. Then the triangle is similar to the sine, but has a sharper tone. And then the square has a sort of buzzing noise to it. And then finally, the AM wave has a sort of vibrating or pulsating sound. So next, we have a drop-down menu for the frequency, which is in hertz. It goes from 440 to 784. And basically, the lower the frequency, the lower the pitch, and the higher the frequency, the higher the pitch. And we can observe this by doing a high pitch on, for example, the AM wave. And you'll hear a higher pitch. Let's choose a medium pitch and apply it to the triangle wave. And there you go. So as you've probably noticed, the waveforms are being graphed here. And one of the issues we actually ran into with this is that our graphs are being too condensed. Like the data points were all very condensed and you couldn't properly see the waves. It was all just one big block. And one way we overcame this was by using downsampling, which is where you use less data points to make the same shape. That way it's easier to see. So that was one thing that we did to solve that. And you can actually save this this sound from the synthesizer into one of the slots in the 3x3. So what you do is you select which sample you want, sample 1, and you can save this. Actually, no, it's here. You can save this in sample 1 here, and then you click, then play. Then you get the audio right there. And we can do another one for the AM wave, let's say with maximum frequency. Let's just play this one more time. So then we can save this to sample 2. Here. And play. Then you have it right there. And you can see the audio waveform here as well. So the next part of the next responsibility I had was the chopping of the audio. And over here you can see we have a slider for start and end, which basically means the user can select which part of the audio they want to play and only play that part. So for example, we can have the end be here and we can have the start be here. And let's actually import the audio first. Import the file. Let's go here. Import this file. Open. Load it to 1. Click on 1 and then play. Yeah, so that will play the audio. And then we can have the start be somewhere here, have the end be somewhere here. We'll save this. We will save it to 1, sample 1. We'll click and then we'll play. And as you can see, it only plays that specific part of the audio that we selected. Another feature that we added was that our start cannot be beyond the end. As you can see, it resets right here, and our end cannot be before the start. As you can see, it resets right here. So the user must pick a start that is before the end and an end that is after the start, so it logically makes sense.